All right. Welcome everyone to the September 12th Dev Call. We have a few big items for discussion today. So the main things we want to talk about are some updates on hub reliability, some thoughts on our new sync model that we've been talking about for a few weeks now, some feedback. We want to collect some feedback on channels. And then finally, we've got a small update on the Warpcast side. I'll try to partition the discussion so that we have enough time to cover all the topics. So we may not get to everything we want to, depending on how this goes, but we will at least cover all of the topics that we've got here. Okay, first up on hub reliability. So we're seeing some delays in Warpcast reading messages. These are like sort of small delays. So let me just bring up the dashboard to give you a sense of this. So if you look at the dashboard today, things are fine. Everything's kind of, processing pretty quickly. But if you zoom it out over the last month, you'll sort of see this gradual trend line where like the time to process is slowly been, going up from like 22 seconds to like a minute and then a couple of minutes. Generally, we're just seeing increased load and some of the things are slowing down on Warpcast side. So we've made some fixes that have brought this back down and things are stable now. And we'll continue working on this, but we just wanted to call out that this is sort of like a slow decay that happened over like a few weeks that we caught thanks to this dashboard and we were able to address. Net impact was your messages previously may have taken 30 seconds to go from Nano to Warpcast. At some point, they may have taken 1, 2, 3 minutes, and now it's back down to 30 seconds. And we'll continue working on this stuff. The second update is we're also noticing, at least on our hubs, which see a lot of heavy merge traffic, we're seeing like delays in hubs processing messages under load. So normally they process it in like 30 milliseconds. We're seeing this go up to like 300 milliseconds. This is invisible to users. I don't think anyone external to hubs is seeing this, but it's indicative that the network is getting to a point where it is putting a lot of strain on some of these critical operations, and we will have to fix this in order to prevent further delays from happening. So that's another thing that we're prioritizing internally, and we're working on some performance improvements. If you are running a hub and you are seeing any of these things like delays in message merging and things like that, do let us know. We suspect that we're sort of ahead of the pack here, given how much we sort of slammed our hubs with load during reconciliation. But NADAR folks or others, if you're seeing stuff, do let us know. Okay, any questions on this before I move on to the next topic? Cool. All right. First big topic of the day, we want to cover ordering. Let me recap really quickly for some of the new folks in this conversation what we talked about last week and why we're going after this problem. So the main reason is, as the network has grown, we're continuing to see more and more problems with sync. And so the problems manifest in a few different ways. One, for example, hubs are sending out messages, they're gossiping to each other. The gossip fails, which just happens because hubs go offline or whatever. And it takes like several hours for another hub to find it, pick up this message and capture it. Another issue is that when two hubs sync, for a variety of reasons, missing on-chain events, hubs state being like slightly ahead or behind, or just sync not completing fast enough, they'll do the sync, but they won't fully catch up with all the messages. And they'll have to sync again, which can take several hours. So again, this ends up with like 1 or 2 messages taking like a lot longer to propagate through the network. And these problems are only going to get worse as the network grows and becomes larger, because our current sync model is like A, too slow to keep up as the network size is growing, and B, it's not deterministic enough. Like you can't just say like, hey, I can complete a sync with this hub and I have everything and I don't have to talk to this hub again. Oftentimes both hubs will have to sync back and forth a couple of times, which is slow, error prone, and doesn't scale. So we haven't seen issues with this for the first 2 years when we were running hubs because things were at a smaller scale. But now that we're larger, the delta graph sync model of like everything is just a bag of messages and just sync them is starting to show some cracks at the edges. And so we want to think about the new sync model that is going to take us to the next 10x or the next 100x from here. And we want to start working on it now because we don't think it's acceptable to wait for things to start breaking and then try to fix it, because this is the kind of thing that takes 1 to 3 months to actually ship. So let me go into like our constraints for this design space, just so folks know how we're thinking about this. So the first thing is we think decentralized global state is necessary and possible. And what this means is, as a developer, you should be able to download like one hub and get everything you need on that hub and stream it to your database. no sharding, no off-chain storage, no data in multiple places. We don't think that's necessary at this scale or the next 10x or the next 100x. And we think this is a far superior developer experience. So we're sort of saying no to any solution that is like requiring you to move things off chain, because that's just really messy for developers like Warpcast and Nanar and Supercast and Airstack to like have to pull all this stuff in. Second thing is sync should be easy. I think that's pretty straightforward and obvious. Third one is posting should be instant and without fees. It's just the best user experience that you get when you pay a subscription and you say I paid, my $2 for storage and I can use the app for the next 1 year. We don't want people thinking about paying per post or like having to load up balances and things like that. That just discourages people from using the network. Next up, whatever solution we take, we want storage and bandwidth to be constrained, which means people can't just flood the network and cause hubs to store lots and lots of messages. And people also just can't cause hubs to keep broadcasting messages to each other. Anything where that happens, you'll just see a lot of DDoS and you'll see a lot of hubs go down. So we need some way to prevent users from doing that. And the last thing is like we think Turing completeness is undesirable. We don't want this to be like a general, like if you manage to create a blockchain that solves all of those constraints, we still think it's a bad idea, because if people can launch other apps, tokens, contracts on this chain, and if they get popular, then people aren't going to be able to cast because someone is like playing with a new tip token or something like that. And that's not an ideal outcome. There are lots of blockchains that are optimized for doing that. And so we'd rather have all of those things live on that chain and social data live on this chain. And that separation is actually great for user experience. Okay, let me pause here. Any questions on any of this stuff before we jump into the solutions we've been exploring? Okay, we posted a couple of weeks ago about 2 solutions. Vripan actually proposed a third one over here, and I'll kind of walk through where we are today in terms of these 3 solutions. So at first, we kind of started off with like equally being excited about all of them, and we've now pared it down to one, or at least we're like 80% confidence that the one that global ordering is the way we want to go. And what we want to do in this call is walk people through the logic that where we've eliminated the other 2 options and collect feedback or try to find edge cases in the others. So first thing we consider do nothing. I think not viable. Like we will just break when things 10x, and we don't want to sit around and wait for that to happen. So we have to do something. So that's off. Second one was account ordering. This was a very simple idea, and we thought it would be easy because you would just introduce ordering per account. So you would tell every user or every application to add sequence numbers for every user. So Alice's first message would be 1, 2, 3, 4, 5, and you'd actually let each signer or each app key do this separately. So if Alice was using Nanar versus Warpcast or Supercast versus Warpcast, each of those apps could just increment their sequence numbers correctly. The big reason this is problematic is we can't retrofit messages with sequence numbers until users come on and sign them. And that's a real pain because some users might just never come back on again. And so you will permanently have to deal with the state of the network where some data is in the old world of having no sequence numbers, and some data is in this new world of having sequence numbers. And that's just going to lead to a lot of complexity. So this made it significantly more expensive than the other solutions. And it turned out that, this solves like 60% of our sync problems, but not 100%. So some of the other solutions were going to be solving much more of our sync problems, and we're going to be cheaper. So we just straight up eliminated this one. Second was app ordering. So this was a similar concept, except instead of labeling each message, you would let apps create bundles of messages. So anyone who was publishing messages could just take a group of user messages, publish it as a bundle, and they would create a set of sequences that you could increment. So Warpcast is issuing bundle 1, which contains Alice, Bob, Charlie's messages, and so on. And other apps are also doing the same thing. This actually looked pretty interesting, and we went deep on this one, but the challenge that we ran into is that bundle conflicts are hard to resolve. So let's say that an app comes back and decides to like reissue bundle number 2 or 3, and that causes a lot of churn in the network, and it would actually introduce a lot of sync issues that are difficult to handle cleanly. And so the downside is the reason we were not excited about this is, again, this felt like you got like 80% of sync better, but again, not 100% of sync issues solved. The benefit was this was going to be a lot cheaper to implement. So we think this is like, call it half the amount of work that the global ordering option is, but it's not a clean solution. You'll still have to deal with some of these sync edge cases and whatnot. The final option, global ordering, is the most expensive one. It's probably going to take us twice as long to implement and execute. But if we get it right, it is going to solve almost all of the sync issues that we're worried about in a very, very clean way, including things like rate limits that have historically been very messy and caused a lot of sync issues. And so we'll walk through like how we're thinking about global ordering. The benefits are everything is like magically better in terms of sync, but decentralizing this has some more challenges and is going to take more time. And we've outlined a few solutions and how we'll approach this one. Sanjay actually put together a fairly detailed table here, walking through all the different options and the trade-offs. You can read this. I'll share a link to this discussion here, and you can read this on your own time and ask questions. I want to spend like 5 minutes digging into the global ordering proposal in a little bit more detail. But before I do that, let me see if there's any questions about this so far. No questions. Wow.
I did have a question. Can you talk a little bit more about the problem where apps would need to reissue bundles? When would that be the case?
So it's not that apps would need to reissue bundles. It's that, let's say that an app issues a conflicting bundle. So an app accidentally reissues bundle number 10 and forgets to increment the sequence number correctly, right? At some point, somebody's going to do this and this is going to happen. The question is, how does the network handle this conflict? And so if you think of a bundle as sort of like, you think of each app as producing its own app chain, right? So you produce message 1, 2, 3, all the way to 100. If for some reason you accidentally reissue bundle number 10, we have to resolve that conflict. So we would have to implement a rule saying that like, okay, look at the hashes of the bundles, take the lowest lexicographic hash or something. But effectively, it's a random choice where the network randomly converges on one of the bundles and says that like, okay, Warpcast for some reason did something dumb and issued 2 bundles, but we're going to agree that this one is the state of the world. But you could end up wiping out the entire other chain. That could be an infinite number of bundles that get wiped out because because they're all chained, anything after that other chain would get wiped out. And handling the pruning and recovery of all those messages just gets really messy. It could create a lot of thrash for users. It could create states where you can't actually like rewind correctly because some of the things have been pruned and removed. And so it feels like a uncommon but very, very messy sync edge case that would make things more complicated. The other like subtleties with the sync model here that are cleaner in global ordering are things like rate limits. So you can't actually rate limit a user cleanly in this model because each app is only guaranteed to have its own data when it's making decisions about rate limits. And so if I exceed it on Warpcast and not here, there'll still be a lot of cases where you end up with a situation that you can't sync, or like Warpcast has a slightly different state than another app because the user did something different there versus here. And so that's not cleanly separated because, again, we don't have a global state and we can't guarantee that you've seen everything before making a decision on this.
That's good. Okay.
Cool. So there's a question on decentralization and how we're thinking about this. So let me maybe zoom to that part of the Snapchain. So one thing is in both app ordering and global ordering, what we're saying is the reason these solutions get more efficient is because you limit the number of hubs that are writing messages. So today, effectively, we have 10,000-ish hubs, and we say that like, hey, every hub in the world is allowed to publish messages. And that imposes some constraints on how we have to think about sync. Like potentially any one of these 10,000 could be issuing new messages. They all have to be like perfectly plugged into the network. We have to be listening to them with equal intensity. And that's obviously hard. Like if you have 100,000 hubs, that's just not viable. What we've observed is that when you look at the network, less than 0.1% of hubs actually write messages. So there's 10 to 100 out of these 10,000 that are actually issuing new messages and producing write messages. And if you redesign the network around that assumption, just like in social networks, only 1% of users create the content. In hubs, you can assume that 1% of hubs create the content and 99% are just there as readers. You can make the network topology a lot more efficient, and you can change the sync model to be a lot more efficient as well. So both app ordering and global ordering basically take that approach of saying like, hey, if you're willing to limit the number of write hubs to like 10 to 100, we can do a lot more efficient stuff with the sync model. The question, of course, becomes how do you decide which 10 to 100 get to write, and how does that process work? There's a couple of ideas that we've explored. This is down here in the Snap chain section of like how we could go about decentralizing rates, right? So whatever project we do, we probably take a very pragmatic approach to reach sufficient decentralization. So initial version will be kept simple. When we're testing it, there'll just be a single right hub. We'll make sure all of the stuff actually works. And as soon as it works, what we would want to do is start introducing multiple hubs. And there's two broad tactics we can do to do this. One is a proof of authority system where you can go and say, hey, people can vote for who gets to run hubs. So we'll give a set of Farcaster users the ability to vote. Everybody can apply to run hubs. And if for some reason the number of applicants is greater than the number of slots, there's 200 applicants and there's 100 slots, you get to vote on it. And so users can vote on whatever decentralization properties they care about. Do you want hubs controlled by different companies? Do you want right hubs controlled by, in different geographic regions, so they're in different sort of political landscapes? Do you want hubs that are like closer to certain areas for faster propagation of time? So you get to vote on that and decide. And the challenge is if a right hub starts performing poorly, like someone says, hey, I'm going to run a hub, and then they just stop running it, it's going to slow down the network, right? And so you want a way to vote these people out and put someone else in that slot so they get to rate. So proof of authority is one way you can approach this. The other approach is to do something that's like proof of stake. It's a little more equitable. You can say like, hey, just copy Ethereum's staking model. You stake some Ethereum on a contract. You now get to run a right hub. And if you fail to run this correctly, this gets slashed. And you can do this in one of two ways. You can either say, hey, all the other hubs get to vote, and if they say you've done something wrong, you lose your stake. Or you can actually try to introduce proofs for this, similar to how Ethereum L2s do fraud proofs. This is a little more complex, but a little more fair, where you can prove that some hub failed to produce blocks, and then they get slashed, and then they go offline. So there's a bunch of different ways to decentralize stuff, and we think it is important to get to the network to a point where there are multiple hubs, and we feel pretty good about getting to that point soon after this is launched. Cool. Let me pause there and see if there's any questions before like covering a quick overview of the Snapchain model. Okay, so the high level of how Snapchain will work is you can think of it as a sort of chain of messages. And the very simple idea is that like when anything happens that's relevant to Farcaster, whether it's on-chain, off-chain, etc., hubs pick it up, bundle it into a group, and issue it as a block, as a snap. And these snaps happen every 15 seconds. So if Alice signs up, you're going to see a snap. And this is her first snap. It's got her on-chain event, and it says, hey, we have a record that Alice has signed up on-chain. And every hub will process this. They'll get this on-chain event. They can verify it by calling the blockchain and making sure that this thing that got reported is correct. But they're guaranteed to have this event before they get Alice's first message. And so when Alice posts the second message, which is hello world, a second snap is generated, and this contains the message, and this is chained back to the first one. And then hubs now are guaranteed to have this on-chain state. They can unpack this, and they can process this message. The thing that separates a snap chain from a blockchain is that you don't actually have to store all of the state. You can end up pruning a lot of these snaps as time goes on. So quick example, we'll look at this case again, but we'll look at it where Alice deletes the message. So we have the same first two blocks. Alice signs up, Alice says hello world, and then we have a third case where Alice sent a delete message saying delete this. In a traditional blockchain, you would store all these three in separate blocks. They would be state transitions, and you would forever have this data that Alice deleted this message, even though it's no longer relevant for everybody. Like we can just wipe this and say like, this never happened. This is not important to sync to all the hubs because this message is a no-op. And in a Snapchain, what you can do is you can actually have the account try, which stores the on-chain event and the message add, just erase the message. And then you can just go ahead and prune these older blocks and say like, hey, these are actually gone. They're no longer part of the network. We only have this latest snap that stores Alice's most recent action and her recent on-chain event. There's some rules around how and when you prune. I won't get into it in this call, but the general concept is that you can prune lots and lots of older state, but still keep the verifiable information. And that makes us much, much more efficient than a blockchain and much smaller than a blockchain and more suited to what we want. There are some trade-offs. I think the main challenges with this are, one, it's just going to take a long time to build out. Like the best argument against this is maybe Farcaster team should go work on something else instead of like trying to scale. Like we could spend energy elsewhere. The second argument is there's limited write access. I think you are going to have 10 to 100 hubs. Like I don't think it's feasible that like 1,000 hubs will be able to write anytime soon, or even anything more than 100. So we have to get comfortable with the idea that like 10 to 100 write hubs is sufficient for decentralization of the network. And the third challenge is there's going to be a little more state management for apps. In the prior world, you can just like push a message to a hub and it's done. You don't have to worry about it. But now it's a little bit more like dealing with blockchains where there's a pending state. And it is possible, for whatever reason, that your message doesn't get accepted and you have to resubmit it and you sort of have to keep track of this as an app. So there's a little bit more complexity here, which apps will have to work. And then downtime is like a new point of failure. Like previously, if you had, if you're building an app, you could run 3 hubs, and if one of them goes down, you just send it to the other one, you're fine, and you can wait for this to come back up. But write hubs are a lot more sensitive. If there's only 10 write hubs and all 10 of them go down, you're not going to be able to publish any messages. There's no send it to a read hub and wait for it to propagate. You have to keep retrying until the write hubs come back up. So that creates more single points of failure. The one thing I will say is like the thing that gives us confidence despite all these trade-offs is, broadly speaking, this is the same model that most Ethereum L2s like Base and Optimism and even Arbitrum use today. And that's actually worked reasonably well for them. And we're going to have a much easier time moving past to multiple block producers or multiple write hubs because our data is independent. Like blockchains actually have this coordination problem where they have to coordinate state. Our write hubs can sort of publish data independently because everything's nicely shardable at the FID. So similar guarantees to ETH L2s to start, and we will have an easier process moving out of it to the next step. Okay, I think there's a bunch of comments in chat. I'll try to go through them quickly. Like it at first. Snap is made every 15 seconds. That's across the whole network, and that's a rough proposal. We think we could potentially go faster than that. We need to do a bit more research. But the 2 things we need to dial in are how fast is every snap produced and how many messages can you put in every snap, and there's some trade-offs we can get there. I suspect that whatever we're able to do now will be 10x or 100x higher than what the network throughput is. So we're not going to be in a place where we're going to be constrained on like running out of snap space or anything like that. Limiting hubs makes sense from a scale perspective, is not that much different from the whitelist that existed before. Okay. Will there be significant changes to the new data structure on the new hub Snapchain? So, Sanjay, if you're on the call, feel free to jump in. Our initial gut is that we don't need any massive data structure changes, which is the main appeal of this, is you don't have to re-sign data. So most of the changes will be internalized to hubs, and if you're just reading stuff from hubs, things should largely be the same. There'll probably be some migration and downtime that has to happen. Like it might be a few hours, it might be a day or 2 where the network has to sort of be upgraded, but this is a one-time cost that we'll have to take, and then everything will be back to normal. And we can plan and coordinate that ahead. There's a bunch of jokes. What's the benefit of pruning old snaps? Just less storage. I mean, today we prune all older content, right? So if you go and write something, we kind of get rid of that stuff. And so you can store and sync things much more efficiently. If we move to a blockchain, the biggest problem we'd have is like state growth would blow. Like everything would be 10x larger because you store every single, like you like, unlike, and like something that's now 3 messages that are being stored. And so pruning lets us have the nice sync properties of blockchains in our Snapchain, but it also lets us have the data efficiency of our current system. Cool. Any other questions from folks before we move on to the other topics? Old data will be pruned. So just to make sure I understand, like the network is going to largely migrate. So it's not like anything that you have today is going to get lost. Everything's just going to like move over. And the way pruning happens is exactly the same as today. Like you run out of storage space, your older messages get pruned, and they just get removed from the network. So that is going to work exactly the same in the new world as it does today. Samuel Huber asked, will the gRPC and HTTP API look very similar? For a lot of stuff, we think that's right. Like some things will obviously change where you can now like get things by snaps and you can pull like a whole snap or submit a snap and things like that. But for the most part, we should have compatible APIs for what applications are doing with hubs.
I think basically the user data APIs will likely remain the same. But internal like sync-based APIs will completely change, and like there's going to be new APIs for dealing with creating, validating blocks, and so on. But like we don't expect the like for example get all casts or like get reactions, and those APIs will all remain the same.
Yeah. Yeah, we suspect that if you're like pulling data over anything, any of the public APIs, like you'll still be able to do that. I don't see any reason why we couldn't support any of those APIs because none of the storage or layout stuff is changing. The sync APIs will change, but that should be largely hidden from any app developer. That's purely like a how do hubs talk to each other, and nobody else is really using that right now. Okay. Last call for questions on anything related to this proposal. All right, so just to recap where we are getting more and more excited about Snapchain. We're not 100% there, but we are like 80% there, and we want to game out a few things, particularly some of the questions about like how will multiple write hubs actually work and sequence stuff together. So we're going to go deep into planning that and figuring this out. The most helpful thing from folks here would be if you can think of edge cases or things that might break in this model, or if you have any high-level conceptual concerns with how things work, or you're like, hey, I don't understand this, can we dig into this? That's the most useful kind of stuff to surface this week, and we'll try to answer it, if not in this dev call, then at least in this document or asynchronously on Farcaster. When will Snapchain V1 go live? We don't have a good date on that yet. We still need to do a bit more planning before we can do that. But I think it's safe to assume that it will be several months away at best. Oh yes, Sanjay actually made a point here about Shuttle. So for like, we generally expect to continue supporting Shuttle, and so if you're on Shuttle today, it will continue to work in the new system. We actually think we'll be able to simplify it a little bit, so things like reconciliation, which Shuttle does, will go a lot faster. So for the most part, it should be same and better, and we will support it. So, you know, we use Shuttle, and we will build our own upgrade path. So if you just follow along, you'll get the same benefits by using Shuttle. Is there a system for which hub gets to create a new snap and the ordering of the chain of snaps? Yeah, the naive thinking here is it could just be like a simple round robin. You have 10 hubs, you get to produce snap 1, next one gets to produce snap 2, cycle around, and then you get to produce 11 again, and so on. We are going to dig a little bit more into that and see if that works or if there needs to be like a different system. All right, I know we have a few more topics, so I will try not to take up more time on this, and we will move over to the second topic, which is channels. Dan, do you want to take that away?
Sure. So high level, we're going to keep this pretty short. We've kind of been clear, I think, the last few dev meetings that channels were kind of in a holding pattern until we figured out what we want to do with them. Well, we've decided that it is the top priority, and we've actually rotated a bunch of folks internally to work on channels. So kind of driving from a product standpoint, design, and kind of both back end and front end. The direction we are heading, and I've previewed with a few people, but if anyone is actually interested, please ping me because it's changing pretty rapidly in terms of the design. So if you have specific thoughts on channels, please send me a DC, and I'm happy to kind of like share the kind of working spec, and then I think hopefully next week have something a little bit more public. But the high level is moving towards what we said kind of at FarCon, cozy corners, which specifically means two things. One, it's moving to a more membership oriented model. So rather than kind of treating channels as kind of these like topics, hashtags, anyone can participate, and then you do moderation, whether manually or using a tool like AutoMod, we're going to move to a model where you're basically explicitly inviting people who can participate in your channel, which I actually think is a much simpler model for most people when they're creating something. People are used to creating a group chat and then curating who's in the group chat, and if you have one bad apple, you can remove that person. And from there, though, you still actually have the public nature of a channel. So the idea is that the work that people are doing in the channel to kind of make the community interesting can effectively be showcased on the protocol, right, and distribute on the protocol, which also allows other people who maybe don't necessarily want to be writing in a channel, but actually want to read it, they can actually go do it. So it is a kind of newish primitive in the sense that we've had this on the protocol today, but it hasn't been as explicit. And I think the best comparable is actually, if you think about like what Clubhouse or Spaces or Tavern does for audio, where you have the concept of people who are on stage and then people who are kind of in the audience. That's effectively what channels is going to be, right? So it's like a public read, permission, write chat.
I have slippers in your bag.
Someone's off of mute. Can we mute that person? I don't know. Anyways, and then the second thing is a change to how the Warpcast default feed will be, is moving channels towards a narrowcast model. So the idea is that you are not, today channels have been focused about topics and distribution. And we even have like a little thing when you go to cast, like add a channel for more distribution. We're going to be shifting to a model where it's basically channel is the cozy corner. And if you want to be broadcast, just cast in your home feed. And some channels obviously will be big enough where you will be getting more distribution than you might have in terms of followers, especially, you know, if you're a member. But the kind of like simpler mental model for people is if I want to be, you know, megaphone, do my home feed, and then if I kind of like want to be hanging out with a specific group of people, I cast into a channel. So those are the two big high level changes. We have a bunch of other things that we're going to be kind of including in this, and I think from our perspective, we are doing more work on this launch than we typically do, at least from Warpcast side of things. So a little less iterative, a little bit more polished, kind of going through the entire surface area of channels, which actually at this point is a lot, and evaluating every bit in kind of both Warpcast and in terms of how channels are designed from a, should we keep as is, should we change, or should we remove? So it will take us a couple weeks to do this, but I think I'm pretty bullish on this direction. And from our perspective, this is like the kind of last big bet on channels. And if it doesn't work, which that's not the goal here, I think we'd kind of have to move towards a simpler model of just like being like, okay, FIP2 exists, but Warpcast itself is maybe not going to be betting on channels as the kind of growth primitive for the protocol. So not to set the stakes too high, but I think like ultimately we're making a big investment in channels. And I think that the other thing that's coming with this is everything will be that's relevant will be available via developer API from Warpcast to start with a plan upfront of like how would we go and decentralize this. So one thing some of you may have seen, I put a cast out. We actually have follow and unfollow channels, which is something people have been asking for a while. Tony on the team actually came up with a new auth model that we can use for other Warpcast APIs that's actually based on signers. So if you have a signer on the behalf of a user, you're actually able to hit the follow unfollow API on the Warpcast side of things. So anything that we're doing related to channels will be available to a tool like Automod or other developers in terms of, you know, management and things like that. Okay, let's go through questions. Okay. Biggest pain points is the channel private. I have no idea to do anything in my app. Channels won't be private. They are just going to be permissions. So the idea would be anyone can read it. All the data is on the protocol. It's just who can actually participate in your channel is going to be a kind of public list of FIDs. And then, you know, you control who is actually in that list. Okay, let's see. Streaks. I mean, Streaks has been an experiment we ran during the summer. So we focus a lot on getting individuals to cast more. And I think varying levels of success. I think Streaks, you know, Varun would say is like there's probably another iteration on Streaks to make them actually really useful and good beyond like the bare bones implementation that we have. I think just not a priority right now in terms of like we've kind of rotated onto what we think the biggest thing is solve channels. And I think, yeah, so that's where I think like streaks and channels sort of work, but like I actually think that there's like a lot of low quality streaks. So I don't think like streaks itself is the thing to drive channels. Serious question. How does this help drive growth? I think it's a couple of things. So one, whenever we kind of sit back and say, okay, like what is the primary thing to drive growth? It comes down to content, and then content is fundamentally about like, okay, can you encourage people to cast more? Can you encourage people to cast about topics that we could use like a defined topic to then actually draw people in? And And I think where we've kind of not worked with channels is they just don't work as broad topics. There's too much. It's not even spam. So spam is relatively easy to detect because it's like so low quality. It's like slop. And it's basically, you know, everyone has their different opinion on what's interesting. But basically, if you were to use a channel and just say, oh, this cast made it to the home feed or whatever, and then you actually push that out to people's feeds, that actually hurts retention for the whole network because the casts are just fundamentally uninteresting compared to something like Twitter, where you basically have the most talented people in the world as it relates to people who write little short bursts of text in any topic. And so I think our view is like moving to a model where channels are smaller, they're controlled in terms of group chats, and then you have to explicitly choose to follow. Will result in content that is more relevant for you. Now, there's a discovery problem, and it's actually an area we're going to be investing in as part of this. But in a world where you have fewer people participating in channels, but people that you are kind of opting in to follow or be in a channel with, similar to a group chat, our view is that the content quality in your feed will actually go up significantly, and you'll have more content to be able to push, right? Like you joining a group of 15 or 20 people that you think are like smart and interesting, and having more of those casts show up in your feed, it increased content supply. So I actually think it's a not immediate driver for growth, but if you can actually get the primitive right and people fundamentally understand what a channel is good for rather than kind of trying to do too many things, I think it solves from a compounding standpoint. I think the other two things is one, it's also just this, I think, big unsolved problem in the network. It's kind of been there since last year. And so getting to some resolution on whether or not like channels is the thing that is working or not, it's actually good in terms of just unlocking creative space, right? So if channels don't work, we can move on to something else, and then we can actually say, okay, this is a finished experiment. I'm optimistic that they can work because I think that there are examples, you know, Late Night Crew is a great example of this. TED, like these actually like kind of vibe-based communities that it's hard to define rather than a topic are I actually think the model of you know, basically group chats that are public. I think that is a high quality set of content on the network that we can actually grow with the better primitive. Okay. Protocol level, anyone can write to a channel, yes, but the way it will work is the Warpcast, and then I would imagine other apps would just follow whatever the spec is. I mean, it's the same way we're kind of working with this like automod like model that we have today. Channels go permission would be something equivalent of hashtags. I don't think to start. I think basically hashtags are just like low quality. Like there's just a lot of content that the slop, mid, whatever you want to call it. I think it's just the harsh reality, and like they're just not that interesting. And I think if anything, the better way to do this is probably AI to find like the best content on the network related to a topic. And then you have like very targeted, basically high status communities that are membership based. Moderate replies to keep out spam bots. The whole point here is you just don't invite the spam bot. So like the model is going to be pushed. The mods, we're actually probably going to add more mods to channels, have the ability to invite people. And then if someone's spamming, you just remove them, just like a group chat. Will Warps be used as membership? I think to start, it'll continue to be the way it is. And I think it will be decentralized at some point if it's working, which then it'll be cryptocurrency payments, and we'll do the same thing where Warpcast will kind of abstract that away from people, and then we will handle the on-chain component. But then any developer would just be able to use crypto to register a channel. Lots of nodes to try before. Okay. Slop making its way. Okay. What do you think the long-term size of it? I think it's probably on the order of 10 to 100 is probably good for most channels in terms of members. I think some channels will be bigger and they'll be able to moderate it and use tools like Automod to kind of enforce things. But I actually just don't think human communities, you lose the famous Dunbar number beyond 150. I think it actually starts to be very hard to manage something. And I do think that people will figure out ways to do it, but I think the cozy corner direction is what we're trying to make an explicit bet on here, rather than having a primitive that scales to everything. That is actually the single most incorrect thing that I've assumed about channels, is that they could scale between 100 and 100,000. And I actually think they're far better in terms of at least the people writing, somewhere on the order of 10 to 100, maybe up to 1,000. And you can have a big audience if you kind of use the 99-1 rule. You kind of like want a very small number of people who are actually producing the content, and then you can offer that content to as many people that would want to read it. I like channels being the priority, but I think it needs to be a mix of. Yeah, so I think that the way to think about this is with this change. I mean, there's a lot of work to go do and kind of still get buy-in from folks. It's going to be incumbent on channel owners, moderators to actually do the inviting. And I think that there's probably another iteration after that of like, okay, if you're not already on Farcaster, how can I invite you to my channel? And as part of onboarding, rather than having you get into the generic algo feed, it actually is a little bit more tailored towards, if Phil Bright Moments invites you, you're actually getting into like a Bright Moments version of Farcaster when you're arriving, because the channel is the potential way of onboarding someone. I think tabs are all like minor optimizations. I think the reality is most people don't click through to channel pages. And I think that is the reality of most people on mobile just want to consume stuff in a feed. And so I actually think that's one of the optimal things about channels is if you think about group chat fatigue or, Discord fatigue, the idea that you can just open up Farcaster and it's going to show you the most relevant content to you based on an algorithmic feed. I know there are a lot of people here that, have their thoughts on algorithmic feeds, but the reality is that's actually what most people want, especially from a reveal preference standpoint. So I think nailing the kind of primitive and then getting the content in people's feeds is the primary focus. And I think that there can be a bunch of iterations in terms of making channel pages a little bit more interesting that people might even want to click through to them. Channel content will be pushed into feeds. Where would the invitations live? It'll start centralized with Warpcast with APIs, and then we will figure out the right model long-term to decentralize it. Varun's probably looking at me being like, hey, we got to get through this. So let me just kind of quickly go through the other questions.
I think the most interesting one's on gating, just token gating, Dan, and just talking about how that might work in the new system.
Yeah, so I've kind of previewed this with John and Automod, and I think that there's a version of the world where it's actually not too much of a departure from where he is. And so I think the APIs will also exist, but this actually allows for very explicit token gating in the sense that you could say, if you own this NFT, you own this ERC20 token, you own this weird combination of tokens, you can actually programmatically invite people to the channel and kind of have to manage through. It's like make sure it's not spammy or whatever. But the idea is making the UX for if you become a member of a community on chain, that could actually immediately then initiate an invite for you to become a member of the channel. We want to tightly couple that flow. And so actually making it really, really good UX is actually like a core requirement as part of this like revamp. Yeah, so Jason, I think that the challenge here is like, I think the too generic primitive has never worked for us. I think it was like being really opinionated is the only thing that's ever actually like clicked, because I think it's just too confusing. And the problem is that the UI that people consume most channels through is going to be Warpcast, at least today. And so I think like making it as simple as possible, that's actually the biggest mistake we made as part of like the revamp we did in May. Is like we just had too many knobs. And I actually think the barbell strategy is the default should be super simple that anyone can understand and they don't have to do a lot of work. And then you have the freedom to go use the APIs and a tool like Automod or anything that any developer would want to build. And you have full customization there. And so I'm actually very bullish on the approach of like make it as generically flexible as possible, but the opinionated version in Warpcast is the default. And maybe that's kind of what you're saying, but I think like what we're trying to hone in on is like, this is what a channel should feel like for most people, but the developer can actually use the kind of like generic building blocks to create their own experience. Okay, cool. I think like, I'm going to leave it here. Like anyone who has any thoughts on channels, please ping me. I will have a public spec early next week where it's just kind of taking into account a bunch of feedback as well as like our initial set of thinking in terms of design that people are able to review. But I think, yeah, we're kind of like making this top priority in terms of like the surface area and Warpcast that we are actually trying to push.
We have one last topic. We'll try to get through that quickly. Horsefactor, Dan, do you want to do the update on the deep link in Composer?
Horsefax can drive that.
Sure. Yeah. Deep linking to composer actions coming pretty soon. We have that just about ready on mobile. We're working on the web side of that. Basically, to start here, this is sort of an incremental building block towards the idea maybe of mini apps. We're going to experiment with this, see what people build, see how folks use it. But we're going to expose the ability to link into a composer action. So right now, this will work. If you have a published composer action in Warpcast, you'll be able to hit it with a deep link. You can use that in a frame button in a link anywhere around the web. And that will just pop open on mobile, the composer action, and on web, the modal to show your action. So small step there towards maybe something more like a mini app model. And we have a few people who we're working with directly to experiment with a few ideas there. So yeah, watch my Farcaster for updates on this. I'll post when it's all live.
One point that I'll add here is I really want people to build these things if we're going to continue to like make an investment. Like I'm going to keep saying that is like, we're going to put the tools in place. Horsefax is driving towards like trying to make the user experience really great. But if it turns into we ship a bunch of stuff and then it's like, oh, well, we just need 2 more features or 3 more features and then it will really work. It starts to turn into this thing where it's like, is there actually enough demand? I think like people building when things are imperfect is the best sign that thing is actually like meeting a demand. So I think like whether it's people on the call who are thinking about building it, or of people who've had this idea, or you know, people when they originally were working on frames, they found them too limited. Like I think this is a great opportunity to really kind of like engage folks to say like, hey, no, this is actually a much more featured platform now. And I actually think that strong examples will kind of make us feel like this is the right direction, because I actually think that there's a version of the world where we say, hey, actually making the existing frames faster, easier to build, like it's really about driving transactions in a feed is an alternative version of the world that is less like kind of like rich surface area focused. I'm optimistic, and there are people on this chat who've built cool apps. So I'm just hoping that people really like get excited about this and actually ship cool stuff.
Cool. All right. Well, I think that brings us to the end. If there's anything that we did not get to or that we missed, please feel free to tag Dan or myself, and we'll respond async on Farcaster. And we'll see you all 2 weeks from now for the next Dev Call.